Welcome to the second module, where we're going to be discussing waves and sound. Now, you might recall at the very start of this subject, I said that physics was about describing the world we see around us. So let's begin by thinking about some waves you might have seen. Perhaps ripples on the surface of a pond, or maybe ocean waves crashing onto a beach. Or perhaps you've been to a sports stadium and seen a Mexican wave go around as the crowd jumps up and down. These are excellent examples of waves, and they illustrate some very important points. Firstly, when the wave moves, it's not the same as what's happening with the medium. A wave is a disturbance moving through a medium. When a wave crashes onto a beach, the water hasn't gone all the way from the middle of the ocean to arrive at the beach. The wave might have done that, but the water has only moved a short distance. Similarly, when you're at the stadium and you watch the Mexican wave go several hundred meters around the stadium, no person has moved around the stadium. The person has moved only slightly. So we need to make a very clear distinction all the time between how the medium is moving and how the wave itself moves. And we're going to be seeing some interesting examples of different ways this can happen. I'll say at the outset, one of the waves you might be thinking of might be light. You might be aware that light behaves like a wave. In fact, in Module 4 of this subject, we're going to be talking completely about how light works. For the moment, though, we're not going to be discussing light because light, it turns out, doesn't need a medium to move in. We're going to restrict ourselves to so-called mechanical waves, where there is a medium moving around, making a wave go through it. Now, when the medium moves, there's more than one possibility for how it can move as the wave goes past. Let's start by thinking about a wave moving on a rope. So here's our rope stretched out nice and tightly, and you're going to grab a hold of one end of it. And again, this is a good experiment for you to try. Physics is about trying things in experiments. And let's wiggle this rope up and down at one end. As you wiggle that rope up and down at one end, you'll send a wave going along this rope. It might look a little bit like this. Now, that wave definitely moves along the rope. That would be the direction the wave is moving. But the medium, that is the rope itself, it's moving up and down at the various locations. And when we have a wave where the medium is moving at right angles to the direction that the wave moves, we call that a transverse wave. So a wave moving on a rope in this form is what we call a transverse wave. And in fact, we'll be using waves on ropes like this quite a lot because they're very easy to draw pictures of and to think about. Now, let's think of another example. Let's think of an example where I've got a whole line of springs joined together, one joined to the other. And what I can do with this line of springs is I could grab a hold of the first spring and I could squeeze it up a bit, compress it. And then once I've done that and I let go of the spring, it'll stretch out and make the spring beside it bunch up a little bit. And now it has bunched up. And of course, this will continue along down the line. This wave of springs bunching up will move along. And you can see the direction that the wave moves is in this direction like this. The direction that the medium, the springs, are moving is the same. The springs are moving backwards and forwards in the same direction as the wave moves. And when that occurs, we call it a longitudinal wave. So this is an example of a longitudinal wave. The main longitudinal wave that we're going to be talking about in this module is going to be sound. Sound turns out to be a longitudinal wave. But again, it's a bit hard to picture. We'll have to wait for a bit later on until we've got all the things we need to discuss waves before we move on to sound. But just keep in mind, it's a longitudinal wave. But before we do that, I want to remind you to stay active on the discussion forum. There's all kinds of things you should be thinking about, waves you've seen, experience you think might involve wave phenomenon. I want you to go onto the discussion forum and maybe discuss the waves that you've thought about and whether they're transverse or longitudinal.